In this VAMAS file we have 4 VAMAS blocks, and these VAMAS blocks represent photoemission peaks that were measured at the same time from the same sample. They've each been assigned a different experimental variable, and they've all been assigned the same element transition field, which is just the number 1. And as a consequence, the VAMAS blocks appear as a single column. To quantify such data, we need these measurements that were performed at the same time to appear in the same row. And this is achieved by altering the element transition field for each one of these VAMAS blocks, and also the experimental variable. So we'll start by changing the element transition field. So I've displayed this first spectrum, and the energy indicates that it's the carbon 1s. So if we go to the edit VAMAS fields, we can change the block ID to be C1s, the element to be C, and the transition to be 1s. And when the VAMAS block is updated, the element transition field has changed, and this causes the movement out of this single column. So now we have 2 columns, one column under 1 and the other under carbon 1s. So we can repeat this process, and here we're looking at the energy. This is an oxygen 1s, so we'll do the same again. Oxygen 1s, oxygen, and 1s. So each time a new element transition field is entered, the VAMAS blocks are separated in terms of columns. We add column for each different element transition field. Let's do this again. This is the aluminium 2p, and the final one is where a fluorine 1s would be. So now we have 4 columns, but we still have 4 rows, and we need these all to be in the same row. So the next step is to adjust the experimental variable so they are all identical. And this can be performed using a toolbar button and a dialog window. That we can give this now a new heading, so we'll call this the sample number, and we'll set a value of, let's say, some sort of significant number for these data. So we end up with a row of VAMAS blocks, and these can now be quantified one against another. So we can end up with a quantification table once we've defined quantification regions. So let's just organize these so we can see all 4 of these at once, and I'll just adjust this once again so that it's a better organization. And then, because these are selected, if I press this button here, I can add regions, and the add regions will make use of the element transition fields to pull in the appropriate relative sensitivity factors for these data. So now this is the carbon 1s, and these are Schofield, so we've got relative sensitivity factors relative to C1s, so that's a value of 1. I look at the oxygen. This is the Schofield cross-section for aluminium anode and oxygen 1s. And similarly we have the aluminium 2p, and the fluorine, again we've got the appropriate RSF. And these RSFs have all been brought in because the element transition fields are correct at the time of pressing the button that will create regions.